Well, hello from Los Angeles. Pretty warm day today out here. I just wanted to cover a little bit on my version 2 of this Slayer Exciter. It's using the typical circuit with a few minor modifications. Let me get this bad boy turned on here for a second. Obviously, the light does great here, but the improvement going on is we can get at least a spark on this thing. Let me see if I can get myself focused here. A respectable spark, not anything amazing, but we get a good spark off this thing. This little fluorescent tube, it doesn't really do that much. I've also got one of these plasma balls here, and that makes a nice little stream radiating off there. Whoa. Let's see if we're still working here. Knock the thing over. Yeah, it's still working. Okay, what I got here, didn't have a PVC handy when I started this one, so I used the shaft part of an old vacuum cleaner, and I've got 900 turns of 34 gauge wire on here, and about 4 turns on the primary down there. And I was blowing a lot of transistors testing this out. I started with the 2N222A small transistor, a bunch of them in parallel, and it wasn't so much an overheating thing as I found that the spacing down here between the primary and secondary, especially if you're using bare wire, you need to keep a gap down there. And I switched to insulated wire and put some little cushion in here to make sure I've got a gap. The other thing I found that just here, you know, I can go close and draw a spark, but it seems like a lot of times if you touch metal to the top load, that would just blow the transistors. I don't know why. I lucked out. I got me a little fan over here blowing on the transistors. That's a 12 volt fan, and I thought I was going to have to add some resistors in there going to the fan so it wouldn't steal all the juice, but I lucked out. It's just with no resistors, just plug it into the positive and negative rails, it worked fine. So what we got here, the standard circuit just has one LED. I got 3 in series. A lot of the circuits just use 1 transistor. I got 2 in parallel here. This capacitor I added, 1000 microfarad 50 volt electrolytic capacitor, really helps the thing a lot. You get a whole lot better spark with that thing, and also lighting of the bulb. I'm using about 25K resistance. I just use 4 100K in parallel to get my 25K there to make sure that those little resistors could handle the current. I put a few in parallel. Let's see if I can go around here and show a picture of the circuit here. In case anybody likes to look at schematics, this is what I'm up to here. Pretty standard, just some small modifications there. Another thing I want to point out in this video, on these TIE Fighter, as they're called sometimes, solar spinners, I got a new design here. Instead of putting the coil between the solar panels, I put it up top at a right angle. It's a lot easier to build these things that way. Let me stop this thing and take it out. I'm breaking stuff today. So you can see what it looks like there. I can get it out of the shadow. So you put the solar panels back to back, and you basically take from one solar panel, it's positive to the negative on the other solar panel. The other connection's positive to negative, just like you shorten the thing out. And where those two short outs meet, you take one wire from the coil to each of those connection spots. Doesn't matter which way you do it with the coil. As long as your coil is sitting at a 90-degree angle to the solar panels, then you're hanging off a magnet, something that'll spin good, and you put magnets on the side pointing right at the center of the coil. I like to use 2 sets. It doesn't matter which polarity you start with pointing out. North could be pointing out or south. It's not going to matter. But once you pick a direction, you need to continue that north-south, north-south to the other magnet set if you're using a second set. Okay, that's about all I got for today. Have a good day.